For our Seagertank project, we will be doing the transportation challenge. Some communities are cut off from areas of social or economic opportunity by lack of adequate transportation infrastructure. How might we design new infrastructure or public transportation to connect communities?
To support the idea of our design, we decided to give some data to show why we just came up with it. 61% of students live closer to home to save money, so public transportation can help this out. $9,122 is the average yearly cost of car ownership, which can get mighty expensive when you're a college student. And 66% of millennials say access to high quality transportation is a top priority for where they choose to live. And making sure that you have easy access to public transportation is a good way of making sure that students can live in anywhere along the metro or the Arizona Valley area.
There is a lack of transportation infrastructure between Chandler, Mesa, Gilbert, and the metropolitan area. We aim to better connect these communities. Our solution is proposing the idea of a drone shuttle. The drone shuttle will be a combination of helicopter, drone, and bus. It will fly over traffic, making it faster and easier for residents of Chandler, Mesa, Gilbert, and the metropolitan area to travel to different destinations of the region. It will be powered by solar energy and electricity.
Okay, so this is our team for our design that we did the Seagertank project on. The first three were Carmen, Yancy, and myself, Natalie. We were the fact finders and follow-throughs of the group, so we did a lot of our research and got information together on as far as what we were looking for and how we were going to make our design. Martin and David were mostly the innovators. They came up with the basic design so we could further our project.
So for our new infrastructures, we're doing drone shuttle flights, which one of the issues, we have to make sure it can fly high enough to avoid roads and airplanes, and high enough where it can avoid the power lines through the cities. Also, since it's flying over the roads, we don't have to construct none of the roads, tracks, or rails, but we do have to construct a landing pad above the parking lots to land the drones. And during the non-working hours, the drones will return back to the depot to recharge.
We decided to provide a map of where exactly we were looking at putting these landing stations for the drones and where people can board and depart the actual design. So as you can see on the east side of Mesa, southeast side of Gilbert, and south side of Chandler, there really isn't a lot of public transportation. Most of what is in Mesa and Gilbert and Chandler are only bus systems. They don't even have a light rail system, and the buses don't even run that much as far as transporting people back and forth. So this is kind of where we were looking at putting our landing stations where they can depart and board, so that way people can easily get to better public transportation that gets them into Tempe and the more populated areas as Phoenix. So the model of our design is going to have 4 propellers on the top to create stability and maximize the carry weight. That way it can hold as much as a bus may hold. And then there are solar panels outlining the top to produce as much energy as it can. Because when we want it to land, we also want it to give more energy to the buildings that it's going to land on as well. So that way it can give energy to the elevators, escalators, or whatever else may be there to apprehend to the customers.
The drone can hold around 40 people, and we maximize the speed around 50 miles per hour, so it's not going too fast to create damage. And also the material that the drone is going to use is a light but durable material, so the engines don't have to do so much work and we can minimize the cost of energy.
So the easiest way to make our design the most efficient in such a highly populated area was to make the drones have driverless technology. These drones will follow the same specified path every day. So for a month before it goes out and actually carries people and transports people, we will have them learn a specified path and drive that path multiple times a day, so that way it can learn its path and know what to do if something were to change. And then that way, after about a month or two, whenever this technology is really instilled into these devices or these designs, then it can go out and actually transport people.
And since this is going airborne and planes have air marshals, we decided to have a highly trained security guard on duty to make sure that all the people in the bus are safe and they don't feel threatened by anyone on the bus or drone. And in case of emergency, the security will be trained to land the drone, and in case of a environmental catastrophe.
So we will also have an air traffic controller, probably at least 2 of them for all of the devices that we have out, or the drone shuttles that we have out. That way they can make sure that they're doing exactly what they need to do. If something goes off path, they can remotely control that and put them back onto their path. And then also make sure that they can come into communication with security, and if anything were to change, the air traffic controller can get a hold of emergency services while the security takes care of whatever mishaps may be happening on board. And then the last thing we wanted to talk about is the actual technology that we'll be using, which is called the fleet learning technology. This was brought about by Tesla, which Tesla put this in their cars so that way the cars could learn how to drive remotely due to different kind of driving situations. And this will be used in the drone shuttles so that way it can adapt to different kind of conditions, or if any transportation was changing, it can go and transport that way.
So for energy and the drones, they have a drone depot where they can go and recharge at the end of the day. And on the landing pads for the drones to land to pick up the residents, and they have a durable solar panel road to generate electricity to charge the tower or to transfer the energy to the drone if needed. And also the battery for the drone is a quick charge and long-lasting battery, which we estimate for a 3-hour charge will probably give around a 20-hour flight.
In conclusion, our drone shuttle will connect communities all over the valley. It will provide fast transportation. It will be comfortable with this wide amount of seating. It will be run by clean energy. It will be inexpensive, and it will be safe due to the high trained security we will have on board.
So the big asked question is, how is this going to happen? We are going to seek in partnership with Valley Metro and funding from SpaceX to begin engineering and construction of the new drone shuttles.